Welcome, welcome to another session of Geometry Math 1250 area and surface area of irregular figures. We're going to talk, this is our 23rd lesson of the year. We're going to finish up our work with three-dimensional geometry now, and then we're going to work our way into a test next week. So, looking ahead, what we're looking at is, for this week, lesson today, lesson coming out Wednesday. Of course, we'll have our typical review questions, and today we'll cover the area of irregular two-dimensional figures, as well as review area of just as a general concept, and then we'll do three-dimensional figures with surface area. And then we'll have a lesson that'll involve volume on Wednesday and a lot of review of today's work. Quiz this week, and then next week we'll get into a test, and then we'll get into final exam review. So that'll put us in right up until the end of the year. That's what we'll do. So without any further ado, let's get started on our review questions. You know the drill. Stop and start every time. Okay. From our last lesson, what we learned was that when we take the products of the pieces of a particular chord and multiply them by each other, for example, the 4 times the x and then the 14 times the 2, those products are going to be equal. Or the way I used to word it in class, and it was a little easier because I'd be standing at like a smart board or back in the old days, a chalkboard, and I would be pointing to these things, but I'll try to do it with my cursor here. This times this. The one's in the same chord. So the 4 times the x, they're in the same chord, is going to equal the 14 times the 2 because they're in the same chord. So 14 times 2 equals 4x. 28 is 4x. Dividing by 4, x is 7. Now we have a sector question. Go ahead. Okay, so sector question here. Now the first thing I want you to do is picture this as being an entire circle. And what would the area of that entire circle be? Well, it would be pi r squared. In this case, the radius is 9, so that would be pi times 9 squared, which is 81 pi. And we're going to give this answer in terms of pi. But we don't have a whole circle. You see, we have 40 degrees here. So that's 40 out of 360, because the whole circle is 360 degrees. So 40 out of 360 is known as 1/9. So I have 1/9 of the area of the whole circle. So if the area of the whole circle was 81 pi, and I have 1/9 of it, then I have 1/9 of 81 pi, which is 9 pi. Okay, next up. And we have a little is too big as a little is too big. A little is too big as a little is too big. Yes, we're doing the big band era swing type of music with our little is too big as a little is too big. So the side of the little triangle, 6, is to the corresponding side of the big triangle, 30. See, the 6 pairs up, corresponds to, matches the 30 side. So 6 is to 30. The little triangle, the big triangle. As 9 in the little triangle matches up to its corresponding side in the big triangle. It's extremely important that you remember when I say little is to big as little is to big, I'm not talking about numbers as a whole. I am talking about corresponding sides of the little triangle and the big triangle. So 6 is to 30 as 9 is to, I didn't write an x here up on AC, but that's what it is. Cross multiplying 6x is 270. Excuse me, dividing by 6, and x is 45. It is 11:09 p.m. on Monday, March the 28th, I believe. And that's when I'm recording this. So if you hear me yawn, it's because it's 11:09 p.m. on a Monday night after a very busy weekend. Okay, next up. Here we go. Key part here, D and E are midpoints. So remember what we learned about midpoints is that if you join the midpoints of two segments of a triangle, you create a segment that's parallel to the third side and half as long. So that's 22. Okay, little inscribed angle action here. Go ahead. All right, so an inscribed angle's on the circle. Anytime you have an angle on the circle, except when a secant meets a chord, that's an exception we're not going to worry about right now. The angle is always half the arc. So if that arc is 86 degrees, then the angle will be half of 86, or 43 degrees. Okay, let's take a look here at an angle outside the circle situation. And let's just be clear, this 16 degrees, that refers to the inside arc here from J to P. It does not refer to the angle. You're trying to calculate the angle. Go ahead. Okay, so the angle's outside the circle. When the angle was on the circle, it was half the arc. When it's outside the circle, it's half the difference of the arcs. So, since the angle is half the difference of the arcs, it's half of 70 minus 16, which makes it half of 54, which makes it 27 degrees. Okay, this is the same question we did before. I don't know why it appears on here, so let me just get through this real quick. All right, here we go. This is a line segments question, not an angle question. So since it's a line segment question, we're not worried about angle is equal to half the arcs. We're worried about segment lengths here. This is the lesson from last Wednesday. Okay, so whoa equals whoa. Whole times outside equals whole times outside. That's what whoa equals whoa means. So for this top secant, the whole thing is 20, and the outside piece, which is right over here, is 5. And for the bottom piece, RT is going to be x plus 4, because x is the distance from S to T, and then 4 is the inside piece. So it's x plus 4 times 4. So I get 100 equals 4x plus 16. That's because I am distributing the 4 to both the x and the 4. Subtracting the 16, I get 4x is 84. Dividing by 4, and I get x is 21. So the distance from S to T is 21. Next up. Now remember, in a question like this, when the angle's inside the circle, it's half the sum. There really are 3 cases with angles and circles. Well, there's a central angle, which equals the arc. But when the angle is not a central angle, there are 3 cases. The angle is inside the circle, on the circle, or outside the circle. If it's on the circle, the angle is half the arc. If it's inside the circle, it's half the sum of the arcs. And if it's outside the circle, it's half the difference of the arcs. With, of course, the one exception of when a secant meets a chord on the circle. But we don't really cover that. Now, excuse me, it's now 11:13 at night. So this angle will be half the sum. So the angle's inside the circle. The measure of the angle is half the sum of the arcs. So the measure of the angle is 55. So that's half of, add the 2 arcs. Add the 5x and then the arc on the backside, which is 10. So to get rid of this 1/2, I could distribute it, but I think it's easier to just multiply both sides by 2. And I get 110 equals 5x plus 10. Subtracting the 10, 5x is 100. X is 20. Okay, now this is a new kind of question that I do not think we've covered yet, but it's review material. So let me draw you the diagram to start with. And the big hint that I'll give you is that the diagonals of a rhombus are perpendicular. Now on a test or a quiz, I wouldn't be able to help you with that sense of direction. But for this question, I can do it. And the big thing is that you have a right angle inside that rhombus, which is going to make 4 right angles. Okay, so go ahead. All the triangles are congruent, so it doesn't make a difference. Only in a rhombus are the diagonals perpendicular. And a square, because the square is a special rhombus. So go ahead, find the value of h. Okay, so what we have here is a right triangle. That's what I'm going to focus on, this bottom piece here. Here's our right triangle with leg squared plus leg squared is the hypotenuse squared. Remember, the hypotenuse is across from the right angle, and the two legs make up the right angle. So one leg is 5, the other leg is 12. 5 squared plus 12 squared is h squared. 25 plus 144 is h squared. 169 is h squared. Square root both sides. H is the square root of 169, which is 13. Okay? It's not the answer, though, because it asks for the perimeter of the rhombus. I just found what one side of the rhombus is. The perimeter is 4 times 13 because of the 4 sides, or 52. All right, let's try this one. Another review topic that we didn't start yet, or that we didn't do a question exactly like this yet. So you're probably thinking, where did I get the red 8s from? Well, look, the whole big bottom base here is 40, and the big top base is 24. It's an isosceles trapezoid, so that means that the distance from E to F, will equal the distance from G to T. So if I do 24 minus 14, I'm going to get 16. And then if I cut that 16 in half, I'm going to get 8. So that's why EF and GT are both 8. Clearly, this is a right triangle. The hypotenuse is the side of length 10 across from the right angle. So if I go with leg squared plus leg squared is hypotenuse squared, 8 squared plus, call AG, or LF because they're the same, call that x squared, or x, I'm sorry. And then, so 8 squared plus x squared is 10 squared. 8 squared is 64, plus x squared is 100. Subtracting 64 from both sides, I get x squared is 36. Square root 36, and I get x is 6. So the length of LF is the same as the length of AG. They are both 6, which is choice 1. Okay. One thing it's important for me to tell you about this is that we're talking about in the diagram below where the chords are parallel to each other. And I don't think I mentioned before this question that parallel chords intersect equal arcs. So what that means is that arc AC is going to be congruent to arc DB. So with that in mind, try to solve the problem. Go ahead. Okay, so altogether on that half of the circle from A through C and D down to B is 180 degrees. But it says the arc from C to D is 70. So if I subtract that, I get 110 other degrees in that half of the circle. But AC and DB are equal, so that 110 gets cut in half. And each of those arcs is 55 degrees. Choice 3. Okay, find the perimeter of the triangle. Now to do this, we have to give you another piece of information that I did not cover the other day. And that's okay. I have no problem because I didn't give you any work on this stuff the other day, and I'm supplementing now to fill out all of the material that you needed to know about circles. And this point is that tangents to a circle from the same point outside the circle are congruent. So that means that this piece up top here has to also be 5. So you see here, this is what we call two tangents. The point of tangency is where it hits the circle. So two tangents from the same point, which is this point up top here, they're always going to be equal. So these are 5 and 5. So when you see that this is 3 and this is 4, that tells you the lengths of the missing sides. Go ahead and find the perimeter. Okay, so That piece has to be 3 because those two tangents must be the same length, and this missing piece over here has to be 4. Now to find the perimeter, I just add them up. So I've got 2 5s, 2 3s, and 2 4s. If I add all of that up, I get 24. Our last piece of review, and the thing that's so important about the review topics is that it gives you a pulse of what you should know at this particular point in the chapter, okay? If you can do all of these questions, then that means you're handling the material comfortably. All right. So now we have two angles outside the circle. We said that angles outside the circle are half the difference of the arcs. Go ahead. Try them both. All right, so first one I think is easy. Second one I think is the most challenging type of problem we've done yet. If the angle is outside the circle, the measure of the angle is half the difference of the arcs. In this case, the measure of the angle is half of 120 minus 40. So that's half of 80, which is 40. Okay, so the measure of the angle A on the outside is going to also be 40 degrees. It's just coincidence that it matches this inside arc. The only reason it works out to 40 is because the difference of the two arcs is 80. Now, for the next one, much more challenging. It's an angle outside the circle, so again, the measure of the angle is half the difference. The problem is that you don't know any numbers on either of these arcs, but you do know two things about them. The first thing you know is that since the measure of angle is on the outside is 80, that means that their difference has to be 160. And as I seem to do, I did put this correctly below, but I did not put it correctly here. All right, let's go back to play. I did have this problem solved correctly for the record. All right, so here we go. Ready? Since this angle on the outside is 80, the difference has to be 160. And don't forget, the outside arc, X, and the inside arc, Y, have to add up to the whole circle, which is 360. So their sum is 360, and their difference is 160. Just add the two equations up. 2x is going to equal 520. Dividing by 2, x is 260 degrees. And in order to get y, since you have to add up to 360 and x is 260, y is going to have to be 100. Okay, so that gets me both of those angles. And that is our review for this particular lesson. Nice thorough review of recent material, not too much older stuff, but a nice thorough review. If you could do that, you're in really good shape.